search to see how we're going to create a histogram of how often each of those names appear in a set of books. So this is more like a text search or indexing type problem, rather than the traditional stuff that we tend to show running on GPUs.
Okay.
And so if we look at this problem, it's essentially a sort of nested loop problem. Can we step back one second?
Oh, I'm sorry, John, could we go back?
So it's essentially a nested loop type problem. We basically, for each of the books that we have, we're going to go then and iterate through each of the names. And then for each of the names, we're going to just basically count how many occurrences of a particular name we find in the stack. The really cool thing is about this central loop here. So this is a very common pattern. We get nested loops, and the inner loop itself can actually be done in parallel.
And it's like begging to be farmed out to
it is,
absolutely.
indeed.
Yeah. All right.
Yes.
So over here, when I look at this, it's great to see you're using Java 8 code, which is awesome. And from what I can tell here, it looks like you're going through a library, which you're doing in sequential as opposed to parallel here. And then you're filtering on books that are selected, and then going through a for loop, this time in parallel, and it turns out you're doing nothing inside.
Well, I am running a comment in the code, yes, that's true. So, of course, the code then inside that loop was too verbose, so we just put a comment in there. But it's been very fast if we run a comment inside the inside. But we're actually going to do the work.
That's how he gets his speed performance.
That's right. Hopefully we're not relying on that, so I'll do. So this is what we have. And what's really cool, actually, is this programming model came out of the Java 8 team. They came out with this programming model in order to solve this problem on multi-core. And when we looked at this, we got very excited because we realized, well, for the first time, we can use the same programming model to do sequential code. By adding the parallel in there, we get multi-core performance. And in Sumatra, our plan is to use the parallel to tag the code that we need to run on the GPU. And that's really nice. We have one programming model, if you like.
That is really powerful. As somebody who used to code in Java during the 1.4, 5, 6 days, I can tell you this simplifies things so much.
Right. So on the next slide, I think we talk about that, sort of just to explain. Again, so this is the one programming model. Again, Java 8 has this great parallel keyword slotted into a stream, and that will run on multi-cores. And the Sumatra JVM prototype that we have, which we'll use for our demo, actually is capable of generating code that goes to the GPUs and giving us further acceleration.
That's awesome. Okay, so with that, I think we're ready to see a demo.
So let's take a look. So I'll start it up over here. So here's the demo that we have.
Looking at the UI for this demo, clearly you're a server-side compiler guy, Gary.
That is true. The UIs is not really my speciality, as you can see, but hopefully it's functional and we'll be able to see what we're up to. So on the left-hand side, we have the set of books that we're going to search through. We're actually going to search through 4 books this time. Again, we've loaded up into the data, we've actually loaded up 5,000 names, and so we're actually going to run in multi-core mode to start off with. So we're actually allowing the JVM to take advantage of all of the cores. And of course, what's really going on here is we have a bunch of Java threads which are going and processing this data, and they're actually doing the sum. Of course, we have a display. We have this my crude display of my UI, which is actually coming in and scanning the data and building up the histogram. It's actually pulling the data out asynchronously as the Java threads is actually populating the data.
And it's incredibly slow, I must say.
While we're checking through the data, and we have a lot of, you can actually count up the inner loops we have. We actually are doing a lot of processing in the background here as we walk through the data. And we should be finished very soon. We should have some music there. So you can see there we took sort of 44 seconds, again, using all of the cores that we had available on this device. Well, actually not all of the cores. We can actually use the GPU.
The GPU that was sitting idle the whole time.
Exactly. So actually what we're going to do now is we're going to switch it all across. And really what we have, so this is the Sumatra JVM sitting on our Ferrari hardware. And to show the previous demo, we actually had to pretend to Sumatra that we didn't have any GPUs. Otherwise it would have started using them. But now we actually allow the GPUs to actually come into play. So there's 2 things that's kind of interesting here is, you'll notice that the GPU is processing the data, yet we're still able to, we're done. So we're still able to actually, whilst the GPU is modifying the memory, the Java threads is coming in and actually displaying the data. That's actually very cool. This is the sort of shared virtual memory in action.
Yeah.
Traditionally with previous GPU frameworks, we would have to move the data off to the GPU. If you like, the histogram would remain static. Maybe we would pull it back for each book,
right.
but we wouldn't be able to actually track it.
In real time, kind of refresh it every time.
Absolutely.
That's pretty awesome, yeah. All right, thank you.
Thank you.